Good morning everyone, and welcome back to our channel, where we continue with our tutorial on programming ACMC lathes. Today we explore how variables integrate with jumps. This lets the machine make decisions. Machines can't decide to move, but can choose paths within a program based on conditions. Variables can be numerical or symbolized by a hashtag. This enables the machine to make decisions, choosing from programmer-defined options. Unlike humans who have limitless choices, the machine can't act freely but can select a path based on conditions within the program. We've seen that variables can be numerical or symbolized, like with Fanuc's hashtag. These variables can be modified, such as a equals b plus a, making a equal 11. Previously I mentioned creating a sum variable by setting c equals b plus a. In practice, x can equal a or x equals a plus b. Use numerical or hashtag variables in Fanuc. Variables can be modified, like a equals b plus a, create sum. Variables by making new ones, like c equals b plus a, x can equal a. Each CNC has its own method. The fact is that these variables will then assume numbers that can also be modified within the program, either as a equals b plus a. In this case, a would become itself plus 6, therefore, equal to 11. And in the previous video I told you that if you have to create a sum variable, you have to do it by creating a new variable, therefore c equals b plus a, or so on. In reality, when we put x can be equal to a, but it can also be x equal to a plus b. Basically, each CNC has its own ways to input these equations. So some CNCs might just require you to input x equals approximately b. They will ask us to put an equal sign on the 15th. They will ask him to write x equal to plus b, other x, open square bracket, a plus b, close square bracket. Just know that it can be done. How it can be done, the CNC machine manual will tell you. So let's open a small parenthesis regarding our simulator, that is Fanuc. Fanuc identifies, as I told you, the variables with an asterisk, number, equal sign, and if I need to do calculations, x, open square bracket asterisk, 100, plus asterisk, 101. This operation will determine the value of x. So, the main operations, for example, always in Fanuc, but all the other CNCs can do it too, obviously, are the plus, the minus, the times, the divided, and also SQRT, which means square root. Okay, a little digression. Regarding the Fanuc manual, let me just open it for a second. I was a bit silly not to have it ready beforehand. For what reason? I'll tell you now. Just give me a moment, because it's crucially important that you take an immediate screenshot of this page right here in front of us. On this particular page, specifically designed for clarity purposes, as you'll see, clearly displayed here is exactly what I just read aloud to all of you. So there's equality, which can indeed be made between these variables, such as addition, plus, subtraction, minus, multiplication, times, division divided by each other respectively. You see quite clearly there exists within these equations both fractions and underscores alongside SQRT representing square roots, precisely explained further later on if necessary, just in case. We leave things at unconditional jump. They work as indicated in the table, but we'll look at that in more detail later. So let's talk now about conditional and unconditional jumps. An unconditional jump is normally defined by go to in English. So if I have a series of blocks and I write go to 10, for example, in the case of Fanuc, the N isn't needed. What will the machine do? It will make an unconditional jump regardless of what's written above, no matter what, to block number 10. Where is block number 10? That's where I determine it. So it can be below. So if we have some lines of code, here we skip them and go beyond, or it can be above. Then it goes back to the beginning and repeats this operation ad infinitum. The point of this, go to 10, is usually integrated with other conditional jumps, or when I have a program with a piece. Let's say this piece. Okay, I have 1,000 pieces to do like this. Then at some point I don't need to do the throat anymore, but I know I have to do another 1,000 with the throat. I go to the section that tells the machine to do the throat. I write go to 10, and once that section is done, I write N10. The machine skips the throat and allows me not to modify the program, but with just 2 lines. I avoid having to delete maybe a long piece of code, which in this case would be simple, but in some cases could be more complex. Conditional jumps are actually more interesting. Conditional jump, something like this. If A equals B, go to 10, and here we need to put something. A and B are 2 variables. If A equals B, I go to block 10, otherwise I continue reading. If A is greater than or less than, greater than or equal to or different, then we check if there's another greater than or equal to or less than or equal to. These are the conditions that can be checked between A and B. So if A equals B, I go to block 10. If A is equal to B, jump to block 10. If A is a return, I jump to a program. If A is greater than B, I go to block 10. If A is less than B, go to block 10. If A is less than or equal to, therefore different from B, I go to block 10. If A is greater than or equal to or less than or equal to, I go to block 10. In other words, when all these conditions are true, I jump to block 10. If these conditions are not met, I continue reading the program. So, what's the point of all this? This stuff is useful for many things, and I can already tell you that when I finish this example, I'll say goodbye, greetings, and kisses, and ask you to like the video. Then I'll continue with a video. I've already posted on the channel that has a practical example of using conditional jumps. Let's do an example of a conditional jump. Let's see if I can do it on the fly, because even with conditional jumps, I often have to think it through. I want to execute a part of the program 10 times. So what do? I need to set a counter equal to 10. Then I start writing my program N10 and write everything I want to do inside the program. Now here, I can write A equals 1. So after doing the whole program, A becomes 9. If A is greater than 0, I go to 10. Greater than 0? Indeed. Go to 10. What's happening? I run the program. A is equal to 10. A equals 1. So A is now 9. If A is greater than 0, when I get here, I go back here. I run the program, which will be 9 will become 8. According to this request, I go back to 10. When A is equal to 1, A equals 1 minus 1, which is 0. No, it's not greater than 0, it's equal to 0. Perfect. At this point, I continue reading the program. You understand that this whole program, with a shift in origin, can be translated each time along the z-axis. So, I can have a program that makes a point with the power tool. I make a point, I drill a hole here, then I move my C and drill a hole here, move my C again, and drill another hole here. Advanced CNC knowledge needed. Grooves. Make. Shift origin. 10 mm. Repeat until A. Reset origin 0. G52 0. Continue. Tailstock attaches to move. I make a groove. I arrive here. I move the origin by 10 mm. I make another one. I arrive here. When I have counted the number of grooves equal to A, I leave. I set the origin back to 0, G52 0, and I continue with my little program. I don't know if you've ever worked with machines equipped with a tailstock or a mobile steady rest where the tailstock needs to be attached to the carriage to be moved left or right on the machine. Normally this tailstock is moved. This is my tailstock. From the turret, here we have a peg. The rung goes up and down lightly. When the turret positions itself exactly at this specific spot, it grabs it and gently and smoothly moves it left and right. But what happens when the pin is pushing in this particular direction? It rests firmly and securely against this wall. When the pin is pushing in the opposite direction, it rests firmly and securely against this wall. When the machine goes to pick it up, the pin needs to be carefully and properly centered with respect to the attachment. Pull. I hope you can see it clearly and distinctly now. I had prepared some magnets. If you can't see it clearly, let me bring it a little bit closer so you can see the example clearly better. After all, I must admit, I'm not exactly something nice to look at. Okay, this program is a very simple program made for the CS, so with variables that work according to R1 equals R2, so. This program isn't Fanuc, it's a subroutine for moving the tailstock. I call this program X when I call PX from the main program. I first set R2 to the point, release it, and then the tailstock. Then run this program. What does this program tell me? It tells me, okay, call tool 0 because I'm moving relative to the origin of the axis. Go to x5, which is a high x compared to x0. And then in G0, go to R1. With M104, pull on the pin and engage the tailstock. Then go to G0, Z, R2. You see that R2 is the level where I want to bring my tailstock. It does whatever it's supposed to do. Unclips the peg. After that, he puts a conditional jump. If R1, R2 plus 10,000 is greater than 0, go to block 16. If it is equal to 0, go to block 14. If it is 2, block. If it is less, go to block 12. In these blocks, what does it do? Adds 3 millimeters. Adds 3 millimeters. Does not add anything. Subtracts 3 millimeters. After which, I have the red that corresponds to the end of the program. M99, M99. In all these conditions, the machine decides whether to block at a time after I call the bezel to arrive with the pin 3 millimeters moved here, 3 millimeters moved here, or none. None is in the case in which the turret, the bezel, has not moved. If I do not do a calculation of this kind, the pin will always hit the corner of my insertion. I hope I've explained a bit how this unconditional jump works, because we haven't talked about tail centers and tail stocks yet. This, on the other hand, is the example we'll be looking at in the video. This, on the other hand, is the example we'll be looking at in the video. What we'll do next. Origin. This is a subprogram to decide whether to create a groove along an outer diameter that has chamfers or radii with a bottom groove radius of a certain size, a starting diameter, and a bottom diameter determined by the variables, a width determined by the variables. And this groove can be repeated as many times as I want along the arc of my outer diameter. So what do I do here? Let's comment together. I've determined the outer diameter of the groove, the bottom groove diameter, the width of the groove, and the thickness of the insert, because obviously with the G75 macro that we studied earlier, we need to specify how much an insert should move, say 3 meters in a 6-meter groove, to widen it completely. So I need the thickness of the insert, the size of the chamfers or radii, the bottom groove radius. You see, these are all variables. The Z position of the left edge, this Z. I need to know where my groove is located. So this is percentage. And I always say percentage hashtag 106, 130. I have 0 for the chamfered outsides, and I put 1 for the radiused outsides. 0 is not to be changed. It's the base origin of my workpiece. Obviously, my workpiece will start with an origin here. I didn't put it here. It's appropriate to do so. Number 132, sorry, cancelled 132, the number of repetitions, which can also be just 1 approximately. Hashtag 133, the distance of my repetitions in total. Now, the first thing I do is set a return number, N10, where G52, that is, the shift of my origin, will be equal to hashtag 131, which right now is 0. After this line, I move 131, but it won't be read by anyone to 0. Which becomes less for the algebraic formulas. So minus 10 this distance, because I can make the grooves in one direction or the other. So if I didn't put minus here, but put plus, I would have made the grooves from the spindle towards the tailstock, and I'm already shifting my origin. Actually, I'm not shifting the origin, I'm shifting the value that I'll assign the origin instead. Here I'm getting closer. Some safety parameters. You see that here, as you can clearly observe, okay, outer diameter groove plus approximately 2 millimeters. So if this is the groove I need to make, I'll keep a distance of 2 millimeters, since the diameter is given by hashtag 100Z equals 106 plus 102 minus 103 minus 0.5. So what is 106? 106 is the position of this edge, alright, plus 102 is the width of the groove. So I've moved my insert here, minus 103 is the thickness of the insert in this particular case, as mentioned earlier, which is crucial, as you might already know, essentially, in this particular context. As a result, therefore, in conclusion, as we have discussed in this scenario, as you can see, as we proceed, as indicated, as demonstrated, as illustrated, as shown, as you can see, which is crucial, as mentioned earlier, essentially, in this context. As a result, therefore, in conclusion, as we have discussed in this scenario, as you can see, as we proceed, as indicated, as demonstrated, as illustrated, as shown. Oh no, I brought it. Minus 0.5. What is this 0.5 for? It's for leaving a bit of excess material on this side. Here, I start making my groove, taking into account the side excess material and the thickness of the insert. I put the advance on and run, my cycle for the throats. You already know this cycle. Obviously, for the final Z, I put hashtag 101 plus 0.5 to leave some excess material here, 2. And for the bottom of the groove, I put hashtag 101 diameter of the bottom of the groove plus 0.5 to leave some excess material here as well. Then I go on to set how much the insert will move each time it widens the groove. And how much the insert will move, of course, it will move in thousandths of a millimeter of its thickness. So its thickness of 3 gets converted into thousandths. So 1000 minus 500, which is minus 0.5. Therefore, a 3 mm insert will move by 2.5. A 4 mm insert will move by 3.5. And a 5 mm insert will move by 4.5. So from the moment you insert the stressor of the insert, Q will automatically adjust. If 130, Q, according to the table I gave you. What I showed you earlier, just wait, okay? I showed it to you before. Go back in the video and print it out. So, if EQ is an equality, if 130 equals 0, I go to N200, so I go here. If it's not equal to 0, I continue. This is the program that will finish the insert once I've executed it with the chamfers. I get to go to 300 and skip the execution of N200 because I've already done it. If I accept this jump, I go to N200, and instead of chamfers, I'll do some radii. Okay, so this area and this area are the finishing of the sides and the bottom of the groove. When I get to the year 300, what do? I take hashtag 132 and subtract 1 from it. So hashtag 132 is indeed my repetitions. If hashtag 132 is greater than, right? Because it's hard to remember it all. If deleted 132 is greater than 0, I go back to block 10 and execute it with 131. That is my origin. Calculated according to this little equation. If it's equal to 0, I go to M99 just to be thorough. I set G52 to 0 and There we have finished our program, allowing it to make choices. Now I'm saying goodbye for a moment, but at the end of this video I will combine this video with the simulator of the program we just discussed together. Remember that with variables and unconditional jumps you could create 4 or 5 subprograms that help you out of tricky situations or simplify your life every time you need to do repetitive operations or complex macros. More holes, more grooves. You can even create roughing macros for simple rectangular sections or whatever the manual guide does. Conversational programming can also be managed with subprograms and macros. Some have already written to me. In the previous video, as you may already know, we discussed various topics, but you might be wondering, why don't you use manual guide? The reason is twofold. First, and most importantly, not everyone has a Fanuc system equipped with manual guide. And secondly, not everyone even possesses a Fanuc system. This logic can be applied to other systems like Fanuc, CS, Sim and Fagor. The same reasoning applies universally. If the CNC system changes, it's not a problem. It doesn't alter the fundamental way of thinking. It merely changes how you input the data. Alright then, I'm signing off for now, but please keep watching this video. As you continue to watch, it might be a bit lengthy as it is divided into 2 parts to also include the simulation and another detailed explanation of the video you just saw. Thank you for being with me, and I enthusiastically anticipate the upcoming episodes where we'll delve into more interesting and engaging topics. Have a great day. A very good morning, everyone, and welcome back to our channel dedicated to turning techniques. What I'm going to do today isn't a typical tutorial, but rather I'm going to present a program I've developed, a sub-program to be more precise, created specifically for a customer whose requirement is to make numerous radial grooves. Their requirement was to have a sub-program composed of variables that could accommodate any type of groove, regardless of its size and depth, allowing them to choose within the sub-program through the variables whether the outer part was made of chamfers or radii, whether to make just 1, 2, 3, 4, 10 or even 20 at a predetermined distance. Therefore, I've created a little program that through these few variables, well, they're not exactly few, but for our purpose they are relatively few, allows us to meet the customer's request as per their specific requirements. The program is this, and I will put it in the description so that everyone can use it in their companies as well. It fundamentally uses variables, unconditional jumps, and so on, or conditional jumps, as you will see. I use the variables to define the outer diameter of the groove, the bottom diameter of the groove, the width of the groove, and the insert thickness, which is essential because in macro G75 I need it to determine the width movements, to make grooves that are obviously wider than the insert, the chamfers, or the external radii in case it's not clear for some. To see the bottom radius of the groove, I obviously need to set a Z position for the groove, and I'll set it to the left edge. I'll establish whether the outer edges will be rounded or beveled by using a 0 or a 1. Parameter 131 is my origin for the first groove, so it will always be 0 and should not be changed. Let's set parameter 132 to 1 for now. Save it. This is the number of grooves I'm going to repeat. N103 is the distance between the grooves, with a plus or minus sign depending on whether the grooves are repeated from right to left, so it will be minus when going from left to right. Obviously, when 32 is at 1, 133 is ignored. 133 is ignored, 133 is ignored, ignored. After that, I'll set my origin by establishing an origin shift, which will initially be a shift of 0 mm,
Under my origin shift, I'll modify my 131 by adding the origin shift to it. So I'll set a safety distance, a rapid distance of 100 for the outer diameter plus 2 meters, and Z will be a count that ensures there's 0.5 m of excess material on the right side. Then I'll use the macro for radial grooves, setting my parameter 106 as Z increased positively by 0.5 to leave 0.5 on the side, and a bottom groove increased by 0.5 to leave 0.5 of excess material at the bottom. Every 3 mm I'll break the chip, and the shift for each cut will be equal to the thickness of the blade multiplied by 1000 reduced by 500. Increased in a positive manner by 0.5 to leave 0.5 on the side, and a bottom groove increased slightly by 0.5 to leave 0.5 of excess material at the bottom. Every 3 minutes I'll break the chip, and the shift for each cut will be equal to the thickness of the blade multiplied by 1000 reduced by 500. Why is this by 1000? Because this value is in thousandths minus 500, because obviously I always have to move a little less than the thickness of the blade. If 130 equals 1, then I ignore this part of the program that defines the groove profile with the chamfers and jump to block 200, where I'll define a profile. After that, we'll take a closer look at the profile, meaning I'll go in from one side, and on the other side I'll create the chamfers with the radii if it equals 0. So different from 1, I continue reading. I create the profile with the chamfers and with Goto 300, which means an unconditional jump, skipping the rounded profile part. Then with this counter, that is 132 minus 1. Only if 132 is greater than Z, I'll go back to 10 and redo everything with the origin of 131 shifted. If this count is, that is 132 1 equals 0, I will end the program. Let's go. We'll practice. Outer groove diameter 100, bottom 5, groove 5 mm wide, bottom 0.5 meters. Outer parts rounded. Execute, restart, single block to zoom. Execute, see radii. Define profile with radii. Finish by trimming groove. Modify parameter, groove deeper. Make it 80 mm deep, 8 mm wide. Execute, simulate, restart single block to zoom, groove wider, starting from Z. 10, 8 mm wide. The outer parts will initially be rounded, and we'll make just one groove. We already have it here. Let's execute it, restart it, and start in single block so I can zoom in. Then we execute, and you see that here we have the radii, and this distance is 5. Let's do the various movements one by one. You see that here I have a profile. I define the profile with the radii. So the left profile, taking into account, of course, the thickness of the blade, which will be zeroed at this point. And here I finish the profile by trimming the groove on both sides and the bottom. Now if I go to modify a parameter, I also modify the groove. So let's make this groove deeper. Let's make it 80 mm deep. That is, let's make it deep up to a diameter of 80 mm and 8 mm wide. Let's execute, simulate, restart single block to allow me to zoom in. And there you see it makes 3 passes, not just 2. And the groove is wider, starting again from Z minus 10, so being 8 mm wide. This thickness will be 2, which is a crucial step in our process. Now we have 2 radii here, and it's important to understand why we need to modify the variable. Let's proceed to variable 130, where we will make a significant change by telling it that this will no longer be 1 but 0. This adjustment is necessary because it allows us to execute 2 fillets instead of maintaining the original radii. Let's simulate this change to see its effects. I haven't restarted, sorry for the oversight. And here, as you can see, we no longer have radii here, but instead we have 2 fillets. This transformation is essential for achieving the desired design. Of course, I can make them 1 mm, but whether they are radii or fillets, I can increase them to 3 mm, which provides more flexibility in the design. Well, I should move them to 3 mm to ensure optimal results. Okay, but let's also move the position of the groove because otherwise it will look terrible, and we'll set it to -15. This adjustment is crucial for maintaining the aesthetic and functional integrity of the design. Let's simulate in this detailed and comprehensive simulation. Stop, restart. And as you can clearly and distinctly observe and notice, now we have significantly more generous and smoother and rounded fillets. Now I want 3 grooves to be carefully incorporated into the design process. So let's go to Edit, and we go to Repeat Grooves, and we set it to 3. Let's set it to a distance, since we made it approximately 8 at least, -15. Let's simulate, restart, start. And now we don't have 3 grooves anymore, but we indeed have 4. I mean, we don't have 1 anymore, sorry, but we actually have 3. I'm going back to my main program, and I'm currently telling it to set it to 70. We are focusing on ensuring that the grooves are not only deep but also sufficiently wide to meet the specified requirements. The target width for these grooves is precisely 5 mm, which is crucial for the design. In addition, a chamfer of 1 mm is deemed more than adequate for the intended purpose. The process will commence from a starting point of 10, ensuring precision and accuracy in the measurements. We want repetitions and distance -8. So it simulates a restart. Here you can see that with the variables and a similar subprogram, I can create a single subprogram that allows me to manage multiple grooves at once, multiple profiles at once. Obviously, with this technology and this technique, you can get creative. The grooves could even vary in depth as I progress. You just need to set a calculator on parameter 101 and have it increase by 2 meters with each repetition. The same technique can be applied with powered tools to define a unique cycle for hexagons based on their size, the cutter, and the depths we want to achieve. This programming technique is really the most flexible because once you have those 7 or 8 subprograms that you need, it makes programming each individual profile much faster and more flexible. The same technique can be applied with motorized tools to define a single cycle for the hexagons based on their size and the cutter and depths we want to make. This programming technique is flexible because once you have 7 or 8 subprograms needed, it makes programming each individual profile much faster and more flexible. Alright, I'll make a tutorial on this and I'll use exactly this program to do it. So follow me because a detailed explanation is certainly coming. I hope I've been absolutely helpful, and I hope you definitely want to use this program in your workshops too. Feel free to copy it from the description and use it whenever you want. There are no copyright restrictions, and maybe modify it. Because, for example, I've already thought about not reaching exactly parameter 100, but going to parameter 100 plus a couple of tenths, and reach it here at parameter 100 with a bevel to avoid leaving shadows, but I'll let you do some of it too. Otherwise you can simply reduce the bottom diameter a bit, increase the bevel, and then physically start from 100.2. There are 1,000 ways to avoid shadows on the pieces, but it's a nice starting point. Thank you for being with me and for following along. I hope I've been of interest to you and maybe helped you a little in your daily work. If you liked the video, as always, I'd really appreciate it if you share it on your social media and give it a thumbs up. If you're not subscribed, subscribe to the channel, obviously. Why do I even need to say that? But all serious YouTubers say it, so I'll say it too, as I'm the YouTuber of tricks. Have a great day, actually a great evening, and thank you all.